We are going to write the equations of the tangent and normal lines to a curve at a particular point. Our curve is given by the equation y sine 2x equals x cosine 2y, and the point is pi over 2 f of pi over 2. Okay, you need two things to write the equation of a line. You need a point and you need a slope. So let's start with finding our point. I know the x-coordinate of the point is pi over 2. I'm going to plug that into the equation and solve for y. So y times the sine of 2 times pi over 2 is going to be the sine of pi. And the sine of pi is 0, so that's going to become 0. And then over here I have pi over 2 times the cosine of 2y. Alright, so now the sine of pi is 0, so I'm going to get 0 equals pi over 2 times the cosine of 2y. And again, that is because this equals 0. Well, I can now divide both sides by pi over 2. 0 divided by a constant, not 0, is still 0. So now I have 0 equals the cosine of 2y. And now I need to move the cosine over to the other side, and I'm going to have the angle whose cosine is 0 equals 2y. Well, there's an infinite number of angles whose cosine is 0. I'm just going to use the first one for this problem. The principal value is pi over 2 is 2y. And when I divide both sides by 2, or multiply by a half, I get pi over 4 is y. So I have my point now. My point is x is pi over 2, and y is pi over 4. Okay, so I've got the first part. I'm finding the equation of the tangent line and the normal line at the point pi over 2, pi over 4 on this curve. Now I need the slope. And the slope is the derivative. And I can see that I'm going to have to use implicit differentiation because in my equation that I'm given, there's no way to explicitly write this equation. There's no way to solve for y. So I'm going to implicitly differentiate, and on top of that, I'm going to have to use the product rule on both sides of the equation. So on the left, the derivative of y is 1, and then the derivative of the variable is dy dx. So I'm first doing the derivative of y times sine 2x plus y times the derivative of sine 2x. The derivative of sine is cosine 2x. The derivative of 2x is 2, and of course it's an x, so I get a dx dx. Well, looks like I'm going to run out of room here, so I'm going to do the right side of the equation down here. So the derivative of x is 1 dx dx times cosine 2y. I'm not touching that. This is the first half of the product rule. Plus x, oh, you know what I forgot here? I forgot my y. I'm going to squeeze a y in here in my product rule. Sorry about that. Y times the derivative of sine 2x. This is the derivative of sine 2x. Okay, let's go back to the right side of the equation. I have the derivative of x times cosine 2y plus x times the derivative of cosine 2y. So, the derivative of cosine is negative sine, also of 2y. The derivative of 2y is 2, and then the derivative of y is dy dx. Alright, let's clean this up and just write this in one line. So I have dy dx sine 2x plus 2y, I'm going to move that up here, 2y cosine 2x. Now over here, dx, the rate of change of x with respect to x is 1, and that shows up again on the right side of the equation. So then I have equals cosine 2y and then minus 2x, let's put the coefficient out here, sine 2y dy dx. Okay, there's a lot going on there. I'm going to plug in the point. Pi over 2 pi over 4. So I get dy dx times, when I plug pi over 2 in there, I get the sine of pi. That's going to be 0. That's nice. Plus 2 times pi over 4 times the cosine of, well, when I plug pi over 2 there, I'm just going to get a pi. And the cosine of pi, recall, is negative 1. That's going to equal the cosine of, when I plug y as pi over 4 in there, I'm going to get pi over 2. And the cosine of pi over 2 is 0. Minus 2 times x. Well, that's going to give me minus 2 times pi over 2, or pi. And then the sine of 2 times pi over 4 is the sine of pi over 2, and then I have a dy dx. Alright, let's go through and write that. See what we have? We have a 0. So this whole thing is 0. Because the sine of pi is 0. Then I have pi over 2 times negative 1. The cosine of pi over 2 is 0. And here I have pi times 1 times dy dx. Alright, when I write it all out, what do I have? Negative pi over 2 equals negative pi dy dx. Negative pi dy dx. Okay, so what is dy dx going to equal? It's going to equal negative pi over 2, and now I need to divide by negative pi, or multiply by negative 1 over pi, and I get 1/2. And this is the slope of the tangent line. Alright, we have all the information we need. We have the point, remember we found the point up here, pi over 2, pi over 4, and we have the slope of the tangent line. So I'm ready to write, first I'll write the equation of the tangent line. Let's scoot down a little. So my tangent line in point slope form is y minus pi over 4, that's the y coordinate of my point, equals 1/2 x minus pi over 2. And if you recall, the normal line has a slope that is the negative reciprocal of the tangent line, because the normal and the tangent are perpendicular. So that means if the tangent line has a slope of 1/2, the normal line must have a slope of -2. So now my normal line equation at the same point, so it's still y minus pi over 4, and it's still x minus pi over 2, but now the slope is -2. And there are the equations for my normal line and my tangent line. See if we can back it up and get a big picture here. Okay, there's all the work from our problem.